this first round anyways, so hopefully you won't have a heart attack, but most of these are not that difficult once you can see your way out of it. So it says solve the following equations for x. So that means every time I'm going to try to get an x equals situation. You've got to know your properties. I mean, you've got to know not the names necessarily, but you have to know what you can do. And remember, this is the thing. Anything, and there's multiple ways to solve these. It's not just one way, all right? So that's the first thing you have to get in your head. I may solve it one way, you may see it another way. That's okay, all right? But, did I ever turn it on? No, I didn't. Come on. It does not want to turn on this morning. There it goes. Okay, so there's multiple ways to solve these. I may solve them one way, you may solve them another. It's whether you used your properties correctly and whether you got to the answer. That's the key. Remember, anything you do to one side, you have to do to the other side of the equation. And you've got two sides. So this says solve for x. I'm going to subtract 3b first. Because I know I've got to get this, I got to get that x by itself. So if I do that, I've got ax is equal to 2f minus 3b. Everybody comfortable with what I just did? Yes or no? Yes. Okay. So I essentially just zero paired and brought this over here. Now, what operation is this? When I have two things next to each other, what operation is it? Multiplication. How do you undo multiplication? Division. So if I divide this by a, I divide this by a, and I've got x is equal to 2f minus 3b divided by a. That's your answer. Now, I could have done this. At this step, ax is equal to 2f minus 3b. Remember, I have to do whatever I do over here, I have to do to each term. So that means I could have written it more like this, okay? And it still would have been correct. Ax is equal to 2f over a minus 3b over a, and we're good to go, okay? Either answer would be acceptable, okay? When we divide a binomial or an expression, what we're saying is we're dividing this by this and we're dividing this by this, okay? We can write it as one or we can put it separately. Whatever you're more comfortable with, it's the same answer, okay? Bother you or is that okay? Everybody okay? All right, let's do number 3. So we need to solve this for x. First thing I want to do is get rid of this 4. Okay? So how do I do that? Multiply everything by 4. So if I multiply this side by 4, I multiply this side by 4, right? So I end up with these canceling each other out. And I end up with x plus b is equal to 4c. Anybody have a problem with that? Pretty simple, right? It looks complicated, but it's not. Then I'm going to subtract b, and I end up with x is equal to 4c, take away b. Not too bad, right? Everybody all right? Okay. Let's do 5. Oh, Lord, fractions. Denby, gonna have to get over them. You're gonna have to love them, okay? Now, if you're subtracting or adding with fractions and they're two different ones, we can go about this. There's 2 different ways we could do this. I could multiply everything by 42, couldn't I? But that would leave, that probably is the easiest way to go. Or, because that's the least common multiple of 7 and 40 and 6. I'll do it 2 different ways. How about that? How about we do that and show you? Okay? Let's do it the way I think that most of you would think of doing it, to keep it there like this. Okay, well, we can do this. We'll do it on the back since we have plenty of room. 5. We have x over 6, take away x over 7 is equal to AB. And then I'm going to rewrite it over here because we're going to do it 2 different ways. Okay? I'll make my screen just cover a little bit more. All right. First way, I'm going to make my common denominator a 42. Okay? So if I put this over 42, I've multiplied x over 6, 42, and I've got what? 6 times 7, so that would be 7x, correct? Everybody agree? Or 7, I could write that as 7 over 42x. Everybody agree? Yes or no? X over 7 is equal to 6 over 42x. Everybody agree? Yes or no? All right. So I've got 7 over 42x. Now, did I change anything equality over here at all? Is 7 over 42 the same as 1 over 6? Okay, so I don't have to do it to this side. Okay, I haven't changed anything over here. It's still the same because 1 over 6x is the same as 7 over 42x. It's just the simplified version of it. Okay, so I've got 7 over 42x subtract 6 over 42x is equal to AB. Remember, we're still trying to solve for x, right? So let's do this math. 7 take away 6 is what? So now I end up with 1 over 42x is equal to AB. How am I going to get rid of that fraction? Multiply by the inverse. Do you see how handy that little tool becomes? You can just love that tool. I cancel my 42s. I end up with 1 over 1, which is 1, which is x is equal to 42 times AB. It's just very abstract, okay? You have to be able to work in the abstract world. That was pretty simple, wasn't it? Okay. What if I'd come over here and done 42 over 1, 42 over 1, 42 over 1, because I have to do it to each term, okay? All right. I would have done this. 6 goes into 42 7 times. 7 times x is 7x. 1 times 1 is 1, so I'm done with my fraction. 7 goes into 42 6 times. 6 times x is 6x. And I have over 1, so I'm done with my fraction. 42 times AB is 42 AB. And I would do 7 minus 6, and I would end up with x is equal to 42 AB. Either way, do you see what I'm saying here is there is more ways to do this than just one. So as long as you are maintaining the equality of your equation, of both sides of your equation, it is acceptable to do it many different ways, whatever way you see it. Okay? All right, so let's do this on back. All right, so let's go with number 2. This is a little more challenging, okay, but it's not bad as you think. First thing I want to do is I want to get my x's on one side, because, for me anyways, because I know I need to do that. So I'm going to do probably the unpopular side, and I'm going to subtract rx from this side, subtract rx from this side. Okay? So now I get h is equal to sx minus rx minus k. I can't combine rx and s because they are not like terms. This says whatever s is times x. This is whatever r is times x. Now I'm going to bring my k over, get rid of my k from that side, and I've got h plus k is equal to sx minus rx. Like I said, there is multiple ways to do this problem, okay? Now, I need to get rid of that S and that R. Do you agree? Okay. So let's think about this. What do both of those terms have in common? X, don't they? So I could probably rewrite this as X S minus R. Would you agree? And I haven't changed anything other than because X times S is SX and S times negative R is minus RX. Do you get that? So I haven't changed the equality. It's just a different way to represent that same expression. Okay? So I'm going to do that. H plus K is equal to X. Because remember, the whole idea here is to isolate X. Okay? Well, now I have, this is multiplication, correct? When I have something like AB and I want to isolate B, what do? Divide by A, okay? So this is the same thing. I want to isolate X, so how do I get rid of S minus R? Divide this side by S minus R. I told you algebra is puzzles. Oh my goodness, it's so much fun. S minus R, and that cancels those out, and my answer is H plus K over S minus R is equal to X, and I'm done. There's more than one way to solve that, but it's what I see. Okay? You may see something different. It's okay. As long as you come out with the same answer. Okay? All right? There's nothing I can simplify here. There's nothing I can do, so we're done. Okay? They look complicated, but if you'll just take it one step at a time. And at first, sometimes you're going to make a change, and then you're going to go, well, that didn't do me any good. Now I got to move that back over. That's okay. All right? That's what this is. X over 5 minus 7 is equal to 2Q. What do you think I should do first? Multiply by what? 5. Yeah, let's get rid of that, because once we get rid of that, then it's easier to deal with. So, remember, yeah, we could do that. We could multiply by 5 first. Either way, there's, like I said, several ways. If you multiply by 5, you have to remember to multiply this by 5, okay? So that one by 5, this one by 5, this one by 5, okay? So that cancels that out. I end up with X minus 35 is equal to 2 times 5 is what? 10Q. I still need to isolate X, correct? So what I can do now is what? Add 35 to both sides. And I would do X is equal to 10Q plus 35. Now, most of you would stop there. I would accept that answer. Don't get me wrong. It is perfectly fine. But eventually you need to get to the point where what did 10 and 35 have in common? 5. So X is equal to 5 times 2Q plus 7 would be the simplified form. And isn't that cool? How many you guys like puzzles? No? Puzzles are awesome. That's what algebra is. I love puzzles. All right, let's look at this one. Solve for H. When you are in this situation, get rid of your fraction first, okay? So what I'm going to do is I'm going to take this whole thing, this whole side, and multiply it by 2, okay? And since it's all multiplication, do you see that? I don't have to do them as separate. When it is B1 plus B2, okay, and that was, let's see, how could I do that? How can I explain this to make it better? okay, let's see if I did it like this. 1/2 and 1/4. I know, this is just, I want to show you the difference, okay? If I had something like this, and I wanted to get rid of my fractions, all right, I would have to multiply each term because they are a plus, all right? So I'd have to multiply this side by 4, this one by 4, this one by 4, and to get rid of each fraction, all right? But here, this is multiplying to this is multiplying to this. Essentially, when I multiply it, I am multiplying 2 times everything. I only need to do it one time, all right? So this side also has to be 2 because this is all multiplication. I'm undoing that fraction multiplication by multiplying by the inverse. So I get rid of that, and I end up with HB1 plus B2, and I end up with 2A on this side, okay? So this is again multiplication, and I want to solve for H. So what am I going to do to get rid of this B1 plus B2 on this side? B3. I'm going to divide. No, I'm not going to make a B3 because this says H times this expression or binomial, okay? So if I divide by B1 plus B2, that side, then I have to divide this side by B1 plus B2, and I end up with H is equal to 2A over B1 plus B2. Good enough? That's what they wanted. So, make sure you use a separate piece of paper. I remember what side. Okay, if I had something like this, I should turn that video off. Well, maybe I should do it here because I've got Brandon doing this all by video. So, sorry, Brandon. All right, let's say I had something like this because this might scare you. All right, V is equal to, although it shouldn't, pi times r squared times h, and I need to solve this for h. Okay? What should I do? But if I just divide by pi, what am I going to be left with on this side? RH, right? Then what would you do? Okay, so you've just taken 2 steps to do what you could do in 1 step. Okay, don't let the square throw you off, all right? So if this is pi squared, then that would cancel both those out. You'd have h is equal to v over pi times r squared, and that would be your answer, okay? There is none of these with an r squared on the bottom, so you're okay with that. Otherwise, you do it the other way. And so I essentially just did one of your problems that you're going to do. Have a great day. Look at your worksheet, and then you'll know which one it is.